jump in a train to realize that I forgot my laptop. But no, I had my laptop with me, but for 30 seconds I was like, oh shit. My on my lap. Yeah, don't ask. It was very early. So I flew via Paris. My plane was delayed, and we almost got a crash with Uber while coming here. I just arrived not even 1 hour ago. So everything is good. So I have some, I have a bunch of demos, so I'm not sure how it will go. So my name is David Delabassee. I work at Oracle, and today we're going to discuss Project Helidon. Before we do so, as I mentioned, even though I have a French accent, I'm coming from Belgium, where I work for Oracle. I'm reporting to the US, and this is someone, so this is me in Sweden in 2017, so at JFocus, and someone in the audience tweeted that it's not a real conference unless you read Oracle's safe harbor statement at least once. So please enjoy. Another disclaimer is this one. I don't know if anybody of you are using those new Mac keyboard, the butterfly keyboard. I will do demos, and I'm pretty sure that some of my demo will not work. It's really because of the keyboard, and I will show you that. So the agenda for today, we're going to discuss Helidon. So I will start with an introduction on Helidon, so what it is, and then I will basically show you Helidon in action. And hopefully we will have some time at the end for answering questions. So Helidon, first, anybody has a guess what Helidon, I mean the term Helidon means? No? Well, it's normal, I didn't know either. So we had to check on Wikipedia. So Helidon is a type of bird with a slender, streamlined body and long pointed wings which allow great maneuverability and very efficient flight. It's basically a bird. No, that's the marketing way of. And the good thing about that type of birds is that they are typically very agile when it comes to cloud. And hence the names. So Helidon.io, what it is? Well, simply put, Helidon is basically a set of Java libraries for developing microservices. It's a project that we have launched October last year, so it's pretty new. It's open source, obviously. It's Apache v2. Everything is on GitHub. So github.com/oracle/Helidon. We're on Twitter. We also have a public Slack channel, and we have this Helidon.io website. So if you just have to remember one resource, one link, just go to Helidon.io. Everything is linked from there, and you will see that it's a very well-designed website, even though it has been designed by Oracle. So before we start, where does Helidon fit? So this is basically our view of the Java microservices framework landscape. It's our view, so don't take this as a kind of universal view of the market, but it's basically how we categorize the market. So we basically see three types of frameworks to write microservices with Java. First, we have the full stack frameworks, such as Spring Boot, for example. Java EE, Jakarta EE would also fit there. Then we have all the frameworks which are based on the MicroProfile specification. They are clearly more lightweight than full stack frameworks. In terms of capability, maybe they don't have all the capability and all the bells and whistles that we have on full stack framework, but they are more agile, more nimble than full stack frameworks. And then at the bottom, we have what we call micro frameworks. Typically very lean, very lightweight frameworks. Again, with less capability than the MicroProfile based one, but those frameworks are also very attractive. So in terms of MicroProfile-based frameworks, we have OpenLiberty, Payara, Quarkus those days. I believe that Tontail is now end of life. On the micro framework side, we have frameworks such as Javelin, Spark, Micronaut, and so on. So where does Helidon fit? And I think that Helidon is quite unique in the sense that it fits at two levels. It fits at the MicroProfile level. So with Helidon, you can write using all the MicroProfiles API. But it also sits at the micro frameworks level, because you will see that Helidon, you basically have choice. We have two programming models, and it's up to you, the developer, to decide which approach you want to use. So we have Helidon SE, which is really a pure Java SE way of writing microservices, so that's why we call that a micro framework. It's basically a functional styles. we are adding some reactive capability, and it's very transparent. So there's no hidden magic like injection, for example. In Helidon SE, you basically write what you want to expect. And we will see some code later on. And then based on that, we have Helidon MP, which basically comply to the MicroProfile specification. It's a more declarative style than Helidon SE. It's really imperative driven. So in Helidon MP, you will obviously use, for example, annotation, something that you will not do on the SE side. In terms of API, we're really talking about MicroProfile. So we are using CDI, JAX-REST, JSON-P, JSON-B, and so on and so on. So if you are coming from the MicroProfile or the Java EE space, that's typically where you will go. You will likely use the Helidon MP programming model. Now, if we look at the architecture of Helidon SE, we have three core components. We have a web server component, we have a configuration component, and we have a security component. So, as I mentioned, there's no hidden magic with the Helidon SE. So it's simple, transparent, no injection, no inversion of control, no packaging tricks, and so on and so on. At the end of the day, what we are generating is a pure Java SE application. Under the hood, the web server component is using Netty. So that's something that makes a lot of sense. Then based on that, we have Helidon MP. So basically, we are leveraging the underlying Helidon SE platform to basically build Helidon MP. Next to that, we have an additional optional project which basically helps to integrate external services. So that's part of the Helidon project, but the only thing that we need to use all those components is basically CDI. So you can take those service integration and use them using any MicroProfile implementation. So if we look at the capability of those three core components, the reactive web server, so it provides simple functional routing model with reactive flow API. That's something that we will see later on. It's built on Netty. It provides tracing, metrics, and health check capability. Again, that's something that we will also leverage on the MicroProfile side. Something which is also important to keep in mind, so we have two levels. We have Helidon SE and then we have Helidon MP. Having said that, there are some capabilities, some API from Helidon MP MicroProfile that you can use on the SE side. Typically, you can use Jersey on the Helidon SE side if you want to do so. JSON-P is also an API that you can use on the SE side. JSON-B is another one. But typically, you will likely not want to use CDI on the SE side. If you want to use CDI, you would have to go on the MicroProfile side. So the reactive web server also provides capability to do static web serving. So it's not a full-blown web server, but if your application, if your services need to do some basic web serving, that's something that you can do directly within your Helidon SE application. Now, if we look at the configuration component, that's a component that you can use to basically deal with configuration. So it supports multiple data sources. In terms of data source, we are talking about properties file, simple files, and so on and so on. It supports different parsers that you can use to process those data sources, so like JSON, HOCON, and so on and so on. And it's also you also have the ability to fetch your your configuration from different sources, such as, for example, etcd or Git or a plain endpoint, those kind of things. And you can also extend that. So you can, for example, have JSON exposed through a Git endpoint, and you can easily consume that. And you can also deal with configuration in specific formats. So if you're not happy with the format that are provided out of the box, you have the ability to extend and add your own parser for dealing with your own configuration format. So basically the idea is that it's an abstraction on all the configuration. Once you fetch the configuration, you will basically have an in-memory tree that you can access transparently from your application. You can also add a puller. So the idea is that once you fetch the once you fetch the configuration, maybe you want to know that that given configuration has been updated. So the configuration in itself is immutable, so it will not change. But if the outside configuration has been changed, that's something that you maybe want to know within your code. So that's something that is perfectly possible. So you can attach some kind of listener to be notified that that configuration properties has been updated, for example. And last but not least, the security component that will basically allows you to secure your application. So out of the box, it provides authentication, authorization, outbound security, auditing, and so on and so on. So right now, we're providing different providers. So there's GWT, HTTP Basic, HTTP Digest, Google logging out on, so there is a Google login providers, there's no IDC, and so on and so on. So I don't have all of them, well, I don't remember all of them, so look at the docs. So that's basically the three core components of Helidon SE, and you will use those components to build your application. So this is a snapshot of a very basic Helidon SE application. So you see that to create a web server, we are basically using some of the concepts that we have on the JavaScript side, Node typically. So web server create, convention over configuration. So if we don't specify anything, we will assume the default value. Once we have a web server created, we need to provide some routing. So this is a simple routing definition. Routing is basically you tie together an HTTP method with some path mapping. So, for example, in this case, I'm just specifying that in this case, I'm going to answer to any HTTP method, so get, put, post, delete, and so on, on this path. And this is called a handler. So a handler basically gets a request and a response, and we can easily chain together multiple handler. So a handler would typically provide a response. So it will send a response to the remote endpoint. That's what we are doing here using the response object, so response.send. So we will send hello Helidon SE. But we can also chain them together. So a handler can also be can also filter, for example. So the idea is that we would have one handler first that will basically invoke another handler that would do something else, and at the end of the day, the final handler would either send the response to the connected remote endpoint, or it will throw an error that will be handled. So we're defining our routing. We are using a build pattern, so we build the object, and the only thing that we have to do to actually bootstrap everything is invoke the start method on the web server. And there we go, we have a small web server that is running in Helidon SE. So, Helidon SE is one thing. Then we have Helidon MP, which is based on MicroProfile. So, anybody doesn't know what MicroProfile is? No? So, in a nutshell, it's basically a set of specifications which were started by Red Hat, IBM, Tomitrab, and Pyara when Java EE was kind of in flux. So they decided to work and try to leverage the Java EE platform to define additional API that are more targeted towards microservices. Since then, Oracle has joined that initiatives, and right now MicroProfile is at MicroProfile 2.2. So it's basically a time-based specification. So every, I think, 6 months they are doing a release with whatever is available. So that's what we are using for the more enterprise side of Helidon MP. So this is Helidon MP. Now let's zoom on the MicroProfile side and see where we are today with Helidon MP. So we first started by supporting MicroProfile 1.0, so JAX-RS, CDI, and JSON-P. Right now, we're supporting MicroProfile 1.2. So that means that we support the configuration API of MicroProfile. We are supporting metrics API, health check, fault tolerance, and GWT auth. Technically, we're also supporting JSON-B on the current Helidon release. JSON-B is part of MicroProfile 2. So right now, we're bidding between MicroProfile 1.2 and 2.2. And obviously, we are working on adding full compliance of MicroProfile 2.2. So, as I mentioned, MP is based on SE. So, if we look, for example, the MicroProfile configuration API is different than what we have on the SE side. Having said that, under the hood, the MicroProfile config API in Helidon MP is obviously using the Helidon SE config API. So this is what REST endpoint looks like in Helidon MP. That's basically JAX-RS. There's really nothing new on that front. That's an API that we have all been using for years. So we have a class with one method in this case. So this is a resource method that we're annotating with the @get annotation. So this one will answer to the HTTP GET request under the path hello pass. And whenever we have a request, it will just return hello Helidon MP. So that's basically the same example that we had before, but written using Helidon MP. So very quickly, I mentioned that optional CDI extension project that is part of Helidon, but that's not something that you need to necessarily use. So right now we are providing 3 extensions, one to connect to a database, one to connect to Redis, and one to connect to the Oracle Cloud Object Store. Under the hood, we just need CDI. So that means that you can use them, given that they are open source, with any other MicroProfile implementation. This is how the data source extension looks like. You first need to define your configuration, for example, using the MicroProfile configuration API. So that's property files that would be, in this case, on the class path. So you define everything in your config file, and then you are using CDI to inject that data source connection. And from that point on, you can use the other data source connection in your Helidon MP MicroProfile code. So let's have a look and see that in action. It's demo. That's a joke that only works in Tokyo, because its demo is a famous shop in Tokyo. So it's demo time. So what we're going to see today? Well, we first look at how we can easily bootstrap Helidon SE and MP application. We'll have a look at some of the config API. We'll check some basic routing, maybe some JSON handling. We'll probably try Docker, and then we'll also have a look at Kubernetes. Because one of the things that we're doing with Helidon is basically, so we're giving you a framework that you can easily use to write web services. That obviously means that at the end of the day, you will deploy those web services. So we are trying to bootstrap how you can easily create, how you can easily Dockerize your Helidon code. Once it's Dockerized, obviously you can deploy it in Docker, in Kubernetes, sorry. So let's have a look at that in action. That would be more clear. So the first thing that I'm gonna do, so is there a way to adjust the beamer? Because it's very, no? Okay. So the first thing that I'm going to do is bootstrap an Helidon application. So for that, we are providing a Maven archetype. So Maven archetype generate, you can use it to bootstrap either an Helidon SE application or an Helidon MP application. Yeah, the colors are very funky. Okay, very good. So if we look at Quick Start SE, we have a bunch of files which have been created for us. And obviously, there's a POM file, so it's basically just a Maven project. So we can use our ID. So let's have a look at what we have here. Let's see. First, let me go in presentation mode. So in the source, so we see that we have a Docker directory, a Java directory, and a Kubernetes directory, and a resource directory. So let's have a look at the Java directory. We have 2 classes, grade services and main services. So this is the application which has been generated. So let's have a look at what's there. So in the main, is it readable at the end, at the back? Yeah. So we have one method, start server. So that's where basically everything will happen. So if we look at the start server, well, what are we doing there? So first we just configure the log manager. There's nothing fancy there. And then we are basically creating a config object. So by doing that, again, convention over configuration, given that here I'm not specifying anything, out of the box, I will have access to the application.yml file that is on my class path. So that means that if I look at my class path, resources, I should have an application.yml. So that's basically where I will store my configuration. So this is a YAML file. It could have been a JSON file, or it could have been well, a Java properties file, and so on and so on. That's something that is handled directly for you by the framework, so you don't have to deal with that. So if we go back to the source, main. So config.create, we have access to our configuration. So the next thing that we're doing, we are creating a server configuration object. Again, for doing that, we are just using the create method, and here we are using server configuration. Here we just want to access the configuration which is in our configuration file. So for that, I can access that configuration using just standard key dotted notation. So the only configuration that I really need here is the server configuration, which is basically, if I look here, that's the minimum I need to provide. Let's see, resource, application, and server is basically just a port and a binding address. That's all I need to provide. Okay, so we have this web server configuration file, so server config here. So what we can do next, we can actually create the web server. So web server create, we pass this configuration file, and we also pass this create routing method with that get the config in parameters. So if we look at the config if we look at the create routing method, that's basically where we will create all our routings for that given web server. So the first thing that we do, we are creating a metrics. We're adding metric support. So we want to have metric support within our microservices. Then we are creating this grid service object, which is really I'll come back to that one later. So let's move on to this SE main. So we are creating this greeting service object. So we are here, and then we just add a web server, and we are providing two. In this case, this is a consumer. So once it's started, we have an accept method. So basically, that's a consumer that will just do something when the web server is actually started. So in this case, the only thing that we are doing, we're just displaying the endpoint of our server, and that's it. And we also have this exceptionally, because basically what we have here is a completion stage. So either the server can start, so we're good, or it fails. In that case, we have the exceptionally method that we can pass it a function to do something in case something goes wrong. And in that case, the only thing that we can do is basically just display the stack trace. So our web server is started. So everything is really happening here. So if we go back to the create routing method, so we have the metrics, we have the grid services. We're also adding health support. Out of the box, the health capability in Helidon is providing a few health checks that you can use. You can also add your own. So typically you would add specific custom health check for your own application. But we are providing a few out of the box, like the heap size, the disk size, and I can't remember which one. Anyway, that's what I'm doing here. Health check, basically I'm just adding the default health check that Helidon is providing me. I build that object. And finally, what I'm doing here, I'm actually constructing all the routing for my method. So I'm adding JSON support. That's something that is, in this case, JSON support is needed either for health or metrics. I never remember which one is outputting JSON. Anyway, so we're adding JSON support. We are also adding our health checks object, so that we can basically we are just registering all our health checks which have been defined. In this case, this is just the default one. We're adding the metrics, and finally we're also defining that our endpoints. So whenever we reach the /grid path, we're going to use this grid services endpoints, which is defined here. So if we look at that guy, there's nothing really fancy here. It implements this services interface, and basically we need to override this update method. So that's basically where we are updating the routing rules. So what we are doing here, we're defining a new rules. So whenever there is a GET request on the on root, so greet / basically, we are using the default message handler. Whenever there is a request that is passing a pass param, we are using this message handler. And whenever there is a request for the put method, we are using this update greeting handler. And we can have a look at those. So basically, this one will just return hello world. So it doesn't change any further handler. It just send a response. So send response, and it just had a world. This one, basically the same, but in this case it uses the parameter which was part of the initial request, so hello and the given parameters. And the other one are just used to update the greetings that we have. So let's see that in action. So this is basically a simple Helidon SE application. So So that's normal. So maybe you didn't have the time, but when we build the services, obviously we are testing the services and the test pass. Web server is down. I think that's because of my firewall. Anyway, I will use it directly, and we'll see that. So if we go here, we have a jar. Quick start SE jar. So that's basically our just the application that we have. So we don't pass anything. We have the hello world. We pass it a param hello voxed, and so on and so on. So you get the idea. So what I can do next, so I have my my application, so my jar. I can easily Dockerize that application using, let's see if I can type, Helidon SE, and well, I don't. So out of the box, we are providing a Docker file. So Helidon SE latest has been built, so now we can Docker run that one. -p8. Oh, let me first have a look at Docker. So there's nothing running in my Docker. So Docker run -p I said 80 and then the name of the image, which is Helidon SE latest. It started, and obviously you see that it works. And now if I do a docker ps, you see that it runs within Docker. So you see that we have the application running in Docker, and now if I kill it, obviously it will not work. So you see that's an easy way to basically from pure Helidon SE code move it to Docker. We can also move that to Kubernetes. So let's see, so I have a Kubernetes cluster running here. Yep. Okay, so get nodes, desktop, okay. So create target, no. Let's see, sorry, get pod. So you see that Quick Start SE is running. So now to access it, I need to get services. Shit, I forgot the name. Quick Start. So this is the IP, and so now it runs within my Kubernetes cluster. So the same code is running within my Kubernetes cluster. So localhost hello world. So basically you saw that very quickly we were able to bootstrap an Helidon SE application, move it to Docker, and then deploy it to Kubernetes. So now I need to make sure I delete it for the rest of my... Okay. Okay, it's empty. Okay. So that's in a nutshell, in a 5-minute overview of Helidon SE. So we've quickly discussed server configuration, startup, routing, JSON. I will discuss JSON in this application. So the next thing that I would like to show you is basically how we integrate Graal with Helidon. So I'm pretty sure that most of you knows Graal. So Graal is a universal high-performance polyglot virtual machine. It provides lots of capability, like the ability, for example, to do no overhead interoperability between different language. But one of the things that we are very keen to use on the Helidon side is the AOT, so the ahead of time compilation that is provided by Graal. So the idea is that you will basically start with some Java code. Graal will take that Java code and it will do the ahead of time compilation of that code, so that at the end of the day what we get is a native Linux executable that will embed a specific virtual machine, because remember that we are starting from Java code, so that means that we need to have memory management, we need to have some thread management, and so on and so on. Typically the capability that is provided by the Java virtual machine. But obviously, given that we have at the end of the day a native Linux executable, that's not something that we can use from the outside world. So basically, Graal will embed the substrate VM directly within our executable. So let's have a look at that. So what I have here is a basic project. So let me first kill that guy. So it's it's a relatively simple application. So let's try to quickly understand what the application is doing. So everything starts from here. So this you can safely ignore. That's something that it's just a workaround for the YAML parser that we're using, because there's a bug there. Well, there is a bug in that parser that hopefully will be resolved very soon. So that's not something which is important. So we are creating a config object, right? Then we are creating a server configuration. In that server configuration, we are defining a tracer. So we want to use basically Zipkins, open tracing. We want to add tracing directly within our application. Then we are creating a web server, like we saw right before. So we create a web server using this specific routing. So we'll check that. So then we start the web server. If everything goes well, we're happy. If everything doesn't go so well, we're not so happy. So let's have a look at this routing method. So that's basically where we define all the routings for our services. So the first thing that we say here, we define here, we basically just get some message from the configuration object. So basically, in this case, that would be from the YAML file in the class path. But it could have been another data source. It doesn't really matter. Then we're defining metric support. So we want to have tracing within the application, but we also want to have metrics out of the box provided by the application. We're specifying a specific custom counter, right? And not only that, we're also adding health check support directly in our application. So in this case, let's see. We are using one of the provided health checks, so heap memory check. And we're also adding here a custom health check. So this one will just basically provide some timing information. So basically since when, well, not even since when, so basically some timing. Nothing more than that. So we have tracing, we have metrics, we have health check. We're also adding security. So we want to secure some of our REST endpoint. So we are basically using the 3 core component of Helidon SE. So Then we just need to basically register all our routing rules. So we register the metrics, we register the web security, we register the health, and then we need to define the endpoint themselves. So the first one, slash, basically we have a standard handlers. Slash admin will be a bit different. So this one is secure. We can check how it is secure if we go in the configuration file. So we see that we are using the configuration file to also define the security. We can define the security either programmatically or through configuration, or we can mix and match. So basically we're defining an HTTP basic auth provider. We have 2 users. Don't do that at home. Don't put your password directly in your configuration file. This is just for a demo. Obviously, we can do alias and store them in a secure store. So we have 2 users. One is as the role admin and the other one as the role user. And then we just need to specify which path we want to secure. So admin can only be accessed by user within the admin role. And /JSON can only be accessed by user that has either a user role or an admin role. So where are we? So okay. So we are here. So we have this admin which is secure. Then we are defining this JSON endpoint which is also secure. And for that we are adding JSON support. JSONB here, so /JSONB, we will also use not JSONP but JSONB. So basically the ability to directly output Java object that will be marshaled to JSON document by the endpoint. So if we go back, oops, sorry. View exit presentation mode. So this is an application that has JSONB support, JSONP support, security, tracing, metrics, health check. So let's try to run this application. Clean package. So the application weight 11 kilobytes, but that's just the jar of the application. I need to add to that all the libraries that are used, and obviously the runtime, the Java runtime to run that. We can run the application. Exec. And I have this endpoint that I can use to access the application. So hello from some YAML config. So this is coming from the configuration file. If I try to access admin, obviously that shouldn't work because that endpoint is secured. And if we look here, there's indeed an unauthorized access. So that's basically the Java side of the story. So nothing really new here. What I'm going to do now, I'm going to use Graal to basically turn that Java code into a native executable. And that's something that takes like two minutes. So let's see. No, sorry. Oops. Yes, executable native image. So what is happening here? So basically, first the application is built using the regular Java toolchain, and then Graal will kick in to turn that into a native executable. That's something that takes a bit of time. So if you have any question, that would be a good time to ask your question. We have like 2 minutes in front of us. No questions? If you don't have any questions, I have good jokes that are not funny.
When you build the project, you target to add the health configuration for Kubernetes and Dockerfile?
when we bootstrap, so whenever I'm using the Maven archetype to bootstrap an application, we are providing the Docker file and the Kubernetes file for Helidon SE and Helidon MP. So this is a quite expensive operation, but that's something that you only do at build time. And I don't know if you can hear, but my fans are kind of going crazy. But this provides benefits. You will see that in less than a minute.
Which one responds faster to HTTP request?
Sorry?
Which one responds faster to HTTP request?
Which one will answer first? It depends, but just wait a minute. You will see. Because so clearly, whenever you are deploying, you don't want to use Graal. That's only something that you will use when your application is basically ready to be deployed. And we're getting there.
I have a question.
Yes?
So, will every single feature and piece of code that I can do in the plain JVM mode work on Graal?
That's a good point. So there are a few limitations. For example, today Graal is limited to Java 8. So, but they're working on adding support for Java 11, and there are other limitations. Like if you are using reflection, you need to configure. You need to do some specific configuration. If you are doing heavy byte manipulation, for example, Graal is probably not a good fit. So there are a few exceptions and few use cases where it doesn't make sense, or simply Graal won't work. But for those type of application, that works. So you see 2 minutes, 21 seconds. So let's have a look at what has been generated. So if we look here, so you see that we have this green Helidon example native image, 26 megabyte. So this is basically our application with everything built in, because it's in this case, this is a Mac native executable. So I can run it. My firewall complain, that's fine. So you see the application started in this case 11 milliseconds. So that's the exact same application. So it has security, it has tracing, it has health check, and so on and so on. So I can show you that. So I will just kill the application and I will start, for example, Zipkin. So 9411. Now let's rerun the application. Yes, I'm allowing that. So now if we look, for example, at Zipkin, so 9411, yes. There's no trace, okay. So now if I go here, so if I access the application, hello from some YAML, if I go back to Zipkins, find trace, I have one trace. Again, this is Java code, basically, that has been turned into native code by Graal. I can try to access the admin. It will not work. Again, if I go back here, that's very small. Find traces, and you see that indeed I was not allowed to access that resources. Not only that, I also have access to health check. I think it's health. No, it's not health. You see that that's an error from my keyboard, because this is not a space. This is a space. So this is basically the health check information that is provided by the application. And here, yes, we have our custom health check provider that is providing just a hub state and some timing information. And this is the heap memory health check provider. That is one of the standard built-in providers that we're also using. What else? So we have security, we have health check, we have tracing metrics. Never remember. Let me move that up a little bit. Metrics. So this is the metrics that are provided out of the box. So again, keep in mind, this is we're starting from Java code, so from a Helidon SE application with JSON B, JSON P support, security, health check, metrics, and probably something else, the web server. So basically, most of the capability that we have. Using Graal, we turn that in, oops, sorry, not the right place. We turn that into a 26 megabyte executable that we can obviously run within Docker. So if I Dockerize that, let's see if I have here. No, I don't have it. Yeah. If I, well, to Dockerize it, I need to basically, no, sorry. Because what I have here is basically not this one, build native. No, I don't have the command here. Well, what we're also providing is basically the ability to Dockerize your code. But for that, we're using Docker because obviously we need to produce a Linux executable that will run within Docker. So we are doing that within a Docker container. It's a bit tricky because we are using Docker and we are using within that Docker the native image capability of Graal to produce a native image that will be run somewhere else. So that is Graal in action. So you see that basically by combining Helidon and Graal, you can achieve a very quick startup time to answer back your question. Because if we look at the startup time of this guy, 18 milliseconds, which is quite fast given that we have tracing support, we have health check, and so on, in a 26 megabyte executable. When it's already started, that's a good point. So the thing that we have to compare whenever we are using Java, for example, hotspot versus Graal, the startup time on the Java side will likely be slower. But the thing that we have on the Java side with JIT, for example, is the optimization that will kick in after some times. We are working on some benchmarks, so I can at this today I cannot really give you any numbers. But in terms of footprint, startup time, memory consumption, Graal is very good. Now, over time, if you have an application, a services that runs for days, weeks, months, it's maybe a better idea to focus on the pure performance aspect by using, for example, all the capability that we have in the standard Java virtual machine. Because at the end of the day, if you are just starting the application once, well, so let's see. That's also something, the startup time and so on, and the footprint that I will discuss tomorrow in my serverless session. And I will discuss Graal from a different angle. So I gave you a very quick overview of Helidon SE. Helidon MP is basically the pure standard MicroProfile API. That's one of the benefits with Helidon. You have choice. Either you are using SE. SE gives us the ability to innovate because we are defining the API and the capability by ourselves. Helidon MP is safer in the sense that you are just using a standard. So you can switch from a different MicroProfile implementation, go back and forth, and so on. And most of the developers know most of the MicroProfile API, so it's easier to start with those ones. So where are we today? So we launched 10.4 in October. We did a bunch of things. And today we are basically at 1.0.1, which was released last week. So in the last few months, there was a strong focus on making sure that we had a 1.0. One of the things that we did in 1.0, we tried to stabilize most of the API. So except for a very few corner case API, the API that we have today, you can be assured that they will be there for a long time. They will not, we won't break them. So in 1.0, we have added support for JSON-B, JSON, so the JSON-B reference implementation, but also Jackson. So again, you can choose which JSON implementation you use. And last week, we've released the 1.0.1, few fixes, and also some specific stuff done for making sure that Graal works within Helidon SE. Something that I should mention is that Graal in Helidon only works in Helidon SE. We're not sure it makes sense to have Graal support for Helidon MP at this stage. In terms of roadmap, so 1.0 is done. We are supporting MicroProfile 1.2. So the next big thing is to work on making sure that we are supporting all the MicroProfile 2.2 API. We're also working on persistence, so adding support for GPA and GTA on the MicroProfile side, but also on the SE side. Maybe it makes some sense. And later on, we have a bunch of things that we would like to do, like HTTP2 support, WebSocket support. We also want to have a website that you can use to easily bootstrap application instead of using the Maven archetype, something that is more user friendly, and so on and so on. So we have a lot of things that we want to do. So in terms of wrap-ups, Helidon, a set of Java libraries for developing microservices. Everything is open source, so you can give it a try. There's really no cost associated with that. Those are the resources. If you just need to remember one link, helidon.io, you have access to all the resources, including the GitHub repo and so on. And we have a very good and well-designed documentation. So we have easy to get started guide that will basically guide you step by step on how to how to bootstrap an Helidon SE or MP application, how to Dockerize it, how to deploy it to Docker, and how to go further. So give it a try. It doesn't cost anything. That's really something that we would like you to do. And if you like it, give us a star. It doesn't cost anything, but that's something that we really appreciate. And with that, almost in time, I'd like to thank you for your time. I'm not sure if we have time for questions. Do we? You don't know either. So anyway, I will be here. So I still have a session tomorrow. I think it's a keynote session on serverless. Just grab me or ask question now. I mean, if nobody kicks us out of the room, I can take questions. No, right now we're really working on having performance numbers for just the Helidon side. So Helidon SE, Helidon MP, Helidon SE with Graal and so on and so on. I mean, we have a long list, a long to-do list. So we're just focusing on ourselves at this stage. That's already a lot of things to do. Yes?
You also have a topic which I think maybe tomorrow on OpenFN.
Just on FN. Yeah. No. So in a nutshell, yes, but we don't necessarily need all the capability that we have in Helidon SE. You will see tomorrow. So Helidon is a fast platform, a serverless platform. You will see tomorrow that a function, a serverless function, is something very basic. It's basically a method that gets some input and produce some output, nothing else. In this case, we have quite a few capabilities that we don't need, like security, all the paths mapping and so on. So we are not using that. And also function, most of the time you are invoking function using HTTP, but function can also be used, invoked using different protocol, like we have a scheduler or maybe a queue, for example. So a function in itself is not tied to HTTP. Here, it's really HTTP endpoints. But we're also, for example, using Graal on the function side of the house. Any more questions? No? Well then, thanks a lot for your time.